Today we are learning mostly information about law of sines and law of cosines. So we're going to start off with the problem here. Which one of these triangles, A, B, C, or D, could be solved using the law of sines? The answer to this problem is going to be C. A does not work because you don't have a full ratio for either of any of the three sides. B does not work because it's all side, 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 and D does not work because it's all angle, angle, angle. So the only answer is C. Okay. So let's say we want to solve the following triangle. So solving the triangle means that you have to find all sides, all angles, etc. So what we know right now is that angle A, is that angle A is 55.3 degrees. That's a 3. Side A is 22.8, and side C, we can label either other one, is 24.9. Now make sure that your calculator that you work in is in degrees, since the problem is in degrees. I don't know what this is or why it's doing it. Okay. So the one relationship that we do have is A to A. When I go to set up to start solving here, I have the sine of 55.3 over 22.8 equals, am I going to have the sine of x or a side of x? So we have the sine of x over 24.9. We are going to cross multiply, and we're going to have times the sine of 55.8 equals the sine of x. I cross multiplied and skipped a step, basically solving for the sine of x right away. So I have 0.903 equals the sine of x. So if I solve for x, I would have 64.6 degrees. Okay, here comes the fun part. We could have a triangle that is 55.3, 64.6, and then how do I find out what the other angle is? I'm going to take 180, subtract 55.3 and 64.6, and I'm going to get that that angle is equal to 60.1. Now, the other thing that could happen, as we well know, actually let's not have that there. As we know, 64.6 degrees could be is a reference angle, and sine is also positive in the second quadrant. So there's a chance that we actually have an obtuse angle that has a reference angle of 64.6. That angle, if we can make it be that, that angle would be the 180 minus 64.6. That angle would be 115.4. So what we have to check is, can we have a triangle that has a 55.3 angle, an obtuse angle of 115.4, and can that form a triangle? Or do we already have enough degrees in our triangle that we can't have an angle as big as 115.4? And the answer is yes. We still have degrees left over to have that angle of 9.3. So essentially, this is called the law of sines ambiguous case. If you are given an angle and a side, so we call this the SSA, there's a chance for an ambiguous case with an SSA. So if we had the angle, let's undo that. If we had an angle of 64.1, the other angle would be, so we'll call that angle, this was A, this was C. What's going on? This was C, so this is angle C. So if angle C is 64.6, or angle C is 115.4. That means angle B is 60.1, or angle B is 9.3. So what we have to find is basically side B for both cases. So side B in the first case is going to form the relationship of the sine of 55.3 over 22. I don't know what's going on. I apologize. 22.8 equals the sine of 60.1 over x. And when I cross multiply, I'm going to get 22.8 equals the sine, times the sine of 60.1 over the sine of 55.3. And we get an answer of 24.04. If we have an angle of 9.3, then our other side B is going to be the sine of 9.3 equals, over x, equals the sine of 55.3 over 22.8. And so we would have the sine of 9.3 times 22.8 over the sine of 55.3. And we're going to get x is 4.48. So the ambiguous case requires an additional possibility of an angle.